Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today we continue with our discussion for pre-PSPM KMS. For question number 1, we try to discuss as much question as possible. For question number 1, A, they give you a diagram like this. The electric field at point 10 cm away from a charge P as in figure 1 is 27 point. Okay, determine the charge of P. Okay, in a way, I think this question doesn't state specifically, but because it says away over here, I just assume that the direction of electric field is actually to the right over here. Okay, so the question wanting to find the charge of P, given that the electric field over there is 2.7 times 10 to the power 6. Okay, you can use the formula of electric field, E equals to KQ over R. So basically you want to find the Q. Make sure you use everything. So this one is R square. Make sure you use everything in SI unit. So the distance is 10 cm, which is 0.1 square. The K constant, and the reason because of the K constant, that's why you have to use SI unit. Then the Q, the charge here is the one that you want to find. Okay, this one is actually 0.1 square. Okay. Should get 3 times 10 negative 6 coulomb. Assuming this one is charge of P, I just put a subscript over there to differentiate with the next question. Oops. Okay, the next question, so it's for A1. Okay, with a reference to figure 1, a charge Q is placed 10 cm away from charge P. So now they put a Q over here. When Q is moved horizontally to the right to a position, so Q is being moved to a position 5 cm from its initial position. So this one lah. This one Q initial position, this one is Q final position. There's 0.54 change in electric potential energy. Okay, so given that delta U, electric potential, is equal to 0.54 joule, which is basically U final minus U initial, what is the charge of Q? So they want to find charge Q. Just now they want to find charge P. So to solve this one, you can use this concept, okay, where delta U is equals to U final minus U initial. So delta U is given. It will be 0.54 equals to U is equals to KQQ over R, but the first Q is P, the second Q is Q lah. So this one is R final minus R initial. Okay, you can take out the K and Q respectively. Not sure if I can fit everything here. Have to bring this one a little bit lower there because couldn't fit. Then it will be 1.0, the final one. Okay, 15 because basically this one becomes 15 centimeter. So 0.15. The initial one would be 0.1. Okay, I just have to calculate. So for me, I would solve the one in the bracket first. So I got here is negative 6 times 10, negative 6 coulomb. The negative means that the charge is negatively charged particle. Just leave it like that. Just leave it the negative. Okay, so basically we cover question 1 and question 2. Now they want to sketch the electric force vector on charge P and Q. So because you now have a positive and negatively charged object, so this one is positive. Okay, this one is P, and then over here we have a Q which is negative. So the charge direction, sorry, the force will be this. Okay, F on P by Q, F on Q. I think I'll put it in the positive. F on by Q on P by P on Q. Okay, the subscript is not that important, but most importantly the label and with the direction. I think this one would be 2 marks. Okay, and the last question, if a charge Q is again moved horizontally to the right to a new position, so digerakkan lagi. So basically this one is being moved horizontally to the right to a new position, and the electric force on it is negative 0.405. How far apart is the change? Okay, so the question still want you to find the distance charge Q from charge P, so that one is straightforward. Okay, if they ask how much it is being moved, then you have to minus. FPQ is equals to KQQ over R square, where one of these is Q and one of these is P. So the force is negative 4.0. I think the negative indicates that it is being pulled to the left, which is makes sense if you look at this. And I think this one, the main reason is because this one is positive. Okay, so because this one is positive, it means that this one is moving to the right. Since this one it says negative, means it is to the left. Anyway, for calculation you don't have to put negative for vector, so you just have to solve. It's 4 times 10 negative 5, sorry, it's 4.05. Basically we want to find the R. Here is 0.2 meter. Okay, and then question B for question 1. The two oppositely charged parallel plates are held 2 meter apart. 4.054 times 10 negative 5 joule of wood is needed to move from left to right. The charge is 2.05. Okay, if you want to draw a diagram, maybe it looks something like this. So that one is the charge, and they want to bring it to the other side. Okay, so this one is positive, so just put this one as positive and just leave it like that. Okay, to solve this one, you can use work equals to, so basically if you want to find the electric field between the plates, normally you will use E equals to delta V over D. So if I want to use this equation, the distance or the separation is given. The only thing that is missing is actually delta V. So you know that work is equals to Q delta V. So work is given 4 times 10 negative 5. If this one is negative, just put it in the negative sign as well. If now you can calculate the delta V, which is 20. Let's substitute inside here. This is 10,000. Okay.